All right, so in 2.8 lesson, kind of backtracking just for a second, but we're going to graph linear inequalities and absolute value inequalities. And it's fairly easy, and this should actually be kind of review for you, where we're graphing a line and then we are shading a region to include all of the values. So let's take a look at this first one. We're going to graph it like we normally would with a regular line, so we're going to get it into slope-intercept form, so subtract that x. And we would start up here at 3, and we'd move down one, right one, down one, right one, down one, right one. Continue on with lots and lots of dots here, and then we're going to draw our line through those points with our arrows on the ends. And then here comes the twist. Let's do the twist. And we are going to look to see if these points could be solutions. So if we're thinking of less than this, we want to be thinking of things that are, I always think of it like an escalator at the mall, like you're riding up the escalator. Well, what would be below would be all the mechanics of the escalator, and what would be above would be you standing on the escalator and then you looking at all the shops around. So for less than, if we looked at 0, 0, 0, 0 would be less than. So yes, that would be a point. -5, 2, yep, that's below this line, kind of where the mechanics are. And then we have 2, -8, so down here, yep. And then we have 6, 3, oh, that would be up here where we would be writing or where the shops would be, so that would be a no. So how do we indicate that all these points are yeses that are below this line, or less than, and this one is a no? Well, that's when we do our shading. So our solid line becomes the line of equals. So now, to indicate that all those points could be, we shade that region below. Okay. So we can always try 0, 0 as a point to see. We don't have to try a whole bunch, but we could just try one point like 0, 0. And since 0 is less than 3, it works, then we know that we want to shade the region that includes 0, 0. All right, so let's go ahead and try a few more after we talk about whether or not it's going to be a solid or dotted line. So when something is less than, then that line, so if we kind of show it as less than, that line is going to be a dotted line, or dashed, however you want to put it. So I'm going to write the word dotted. And then if it has less than, we know it's going to be shading below. Again, kind of where the mechanics of that escalator, if you want to think of it like that. Less than or equal to, well, since it is or equal to, that means that we're going to use a solid line. And we're still less than, so we're still shading below. Greater than would be dotted. But this time, greater than is going to be shading above that line. And greater than or equal to, solid, because of or equal to. And we're still shading above because we're greater than or equal to. All right, so let's go ahead and try a couple of these. So first steps, over here on the left, put the inequality into slope-intercept form. So that's going to be adding 4x. And we wind up with 2y is greater than 4x plus 4. Remember, we cannot combine an x and something that does not have an x, so we just put them next to each other. And then divide by 2. Every single thing gets divided by 2. Okay, so we're going to go ahead and start by putting a dot at 2, and we're going to go up 2 over 1, up 2 over 1, up 2 over 1. Are we solid or dotted? Well, for this one, since we're just greater than, we're going to be dotted or dashed line because it's not equal to. So let's go ahead and make a dotted line and continue that line all the way through the entire graph with arrows at the ends. Now we're going to test a point to see, not on a line. Let's try 0, 0. So that's a pretty easy one. So if we plug in 0 here, That's going to give us 0 plus 2, or 2, and 0 over here is 0 greater than 2. Well, no. So that means we don't want to shade the region on this side. We're going to be shading this side. Now, if that is a struggle for you, you can think of it like y greater. So if we're greater, we want to again shade above where you're going to be riding that escalator and seeing all those shops at the mall. Holiday season. So next, we're going to subtract 2x. And 3y is less than or equal to negative 2x plus 12. Divide everything by 3. So y is less than or equal to negative 2/3 x plus 4. And we're going to start at 4 and move down 2 over 3. And then down 2 over 3. And continuing that, this time we are a solid because we're less than or equal to. So we want to be connecting this with a solid line with arrows on the ends. And this time, let's try 0, 0 again. So 0 in here would give us 4 on the right and 0 on the left. Is 0 less than 4? Yes. So that would mean 0, 0 is a included solution. And is y less than, so we're shading below where the mechanics of the escalator are. All right, I want you to try these last two on your own. This one's already ready to go. And then try number 4 where you're going to change it. And check both when you're ready. All right, so for this one, starting at 5, moving down 1 over 1, down 1 over 1, down 1 over 1, shading above for greater than, or seeing that 0, 0 does not work as a point, so we should not be shading the region where 0, 0 is. Over here, subtract the x, divide by negative 2. Don't forget that you have to switch your inequality sign when you divide by a negative. That's that trick we learned back when we were working with inequalities for the first time. So starting at negative 2, we want to move up 1 over 2, up 1 over 2, and this one's a dotted line because there's no or equal to. So make sure that this is a dashed line. If not, fix it. You can just kind of erase. And then 0, 0 does work, so we want to shade that region that includes 0, 0. The fact that y is greater, we're shading where we would ride the escalator, which would be this top part, greater. All right, let's flip over to page 10. On our last page here, and we're going to write an inequality to represent each of these. And then we are going to take a look lastly at absolute value. So for the first part, let's go ahead and just identify where our intercept is, and then another cross point here, if you can kind of see those blue points. So it looks like we're here at -1 for a starting point. What's my slope? Well, I'm going up 1, 2, 3, and over 1. So that would mean a slope of 3, and I need an x right behind it. And I'm going to put a y on this side. Now let's go ahead and fill in, where are we shading? Well, we're shading everything that is above this line where we would ride the escalator. So that means we're going to be greater. Now, are we equal to? Yes, because there's a solid line, so we want to put that solid line below. Okay, let's do one more together. I'm going to do number 3 with you, and then have you do number 2 on your own. So this one is going through the x-axis. So we're going to be having x, and then we're going through at 4. So this one has a little bit of a weird formula, remember. So now, because our slope is undefined, it's x is our variable there, and we are less because we're to the left. So anything less, we're shading there to the left. So less than, and since we're a solid line here, we want to have our line under here. All right, so try this next one. Again, identify your intercept and your slope. Kind of write that formula, but just leave out the equal sign. Don't do that. And just fill in what inequality you would have there. Check when you're ready. All right, so hopefully you have y is less than or equal to, because we're shading below where the mechanics are, and then it's a negative 1. If you have the 1 there, that's fine. X minus 1. All right, let's take a look lastly at absolute value. So this is a review of graphing absolute value, and then we're just going to do the same thing that we did above. So let's graph it. What our vertex would be on this one would be -4, because remember we do the opposite of the inside, and then a +8. So let's go to -4, 8, oops, and put a dot. Not the one I crossed out. All right, we are going to be a reflection, so upside down, and there's no stretch or compression, so we're just going to go with a slope of -1 and 1 in both directions. And are we solid or dotted? We still have to do that same thing, and it looks like we have a or equal to, so we're going to be solid lines here. And we still want our arrows, because arrows are important. Okay. Now we just need to figure out where we're going to shade. So we could test 0, 0, and we can see if we're going to be shading underneath the V or above our upside down V here. So 0, 0 would be 0 greater than or equal to, well, that would be 4. So if I plugged in 0 there, absolute value of 4 is 4 with a negative out front plus 8. So is 0 greater than or equal to 4? No. So that would mean this is not a solution. So we want to be shading everything that's not near 0, 0. That should be everything above. And since y is greater than, that would make sense. We're greater than above our v. All right, try number 2, that last one on your own, and check when you're ready. All right, we should have a vertex at 5, 0. This one should be dashed. Remember, we need to look at that and see if there's no line, then we need to be having dashed. This one should have a stretch of 3, so it starts at 5, 0, but goes up 3 over 1, up 3 over 1, up 3 over 1, and then up 3 left 1, up 3 left 1. So double check that you have a stretch here. Then test your point 0, 0, and it's a yes. 0 is less than 15. And so that would mean that we want to shade everything, including 0, 0, which is less than our y value there. All right, make sure to put any questions that you have at the bottom of your page, and make sure to ask those in class.